Hi, I'm Dr. K. Prakash, Assistant Professor in CSC Department. Today I will present a lecture on variational autoencoders in deep learning. The main aim of this lecture is to familiarize the students with variational autoencoders. The main objective of this particular lecture is to introduce autoencoders and variational autoencoders. At the end of this lecture, the students will be able to understand the concept of variational autoencoders. The outline of this lecture is the introduction to autoencoders, variational autoencoders, in that the introduction, architecture, intuition about the regularization and mathematical details regarding variational autoencoders and the summary of this lecture. Coming to the autoencoders is a type of deep learning deep learning algorithm. It receives an input and transforms it into a different representation. In other words, here autoencoder is a type of neural network that can learn to reconstruct the images, text and other data from compressed versions of themselves. Here there are three layers in autoencoder, such as encoder layer, code layer and decoder layer. Here, coming to the encoder layer, it compresses the input image and represents in a latent space representation. Coming to the code layer, here it represents the compressed input fed to the decoder layer. Decoder layer functionality is to decode the encoded image back to the original format. Here this is an example for autoencoders. Here mainly we will have encoder and decoder, encoder framework and decoder framework. Here this is the input layer, this is the output layer, this is the actual latent code and these are the hidden layers. Here the number of hidden layers based on the can be selected based on the requirement. So coming to the variational autoencoders, these variational autoencoder was proposed in the year 2013 by Nigma and Welling at Google and Qualcomm. Here it is an architecture composed of both encoder and decoder that is trained to minimize the reconstruction error between encoded and decoded data. So this is the basic architecture. Here the variational autoencoder comprises an encoder network that maps. Here this is an input, here it is an encoder network that maps input data into a latent code, and a decoder network that conducts the inverse operation by translating the latent code back to the reconstruction of data. The main concept is here the input data will be encoded and again it will be decoded back into the original form. Variational autoencoders, intuition about the regularization. What is the importance of regularization? In general, the regularization techniques in machine learning are applied to reduce overfitting or underfitting. So these are the problems occurred during the machine learning process. Coming to the variational autoencoders, the regularization can be done by incorporating Kullback-Leibler divergence term into the loss function. Here the loss function of variational includes the calculation of KL divergence between the distribution of the learned latent variables and a prior distribution, normal distribution. Here this is the formula for calculating KL divergence. A KL divergence term in the loss function will encourage the learned latent variables to have a similar distribution to the prior. So these are the mathematical details of the variational autoencoders. Here there are different assumptions related: latent variables, observed variables, joint distribution of the observed and latent variables, and the main goal of the VAE is to learn the true posterior distribution of the latent variables given the observed variables. So here the continuation for the mathematical details are here the variational autoencoder learns the parameters of the model by maximizing the evidence lower bound, which is referred to as elbow. Here this is the equation for elbow. The first term on the right hand side of the above equation is the reconstruction term. This is the reconstruction term, and the second term is the KL divergence. So here the first term is the reconstruction term which measures how well the variational autoencoder can reconstruct the input data. The second term, KL divergence, measures the difference between approximate posterior and prior distribution. Coming to the summary, a variational autoencoder uses a probabilistic framework to model the data by assuming that input data is generated from latent space according to certain probabilistic distributions. The main goal of variational autoencoder is to maximize the likelihood of the input data. These are the books that you can refer for understanding variational autoencoders. These are the web links. These are self-assessment questions. So you can refer. There are so many other MCQs you can refer. These are the samples presented here. And these are the terminal questions. For example, describe the key components of a variational autoencoder. So what are the key components? Encoder framework and decoder framework. Like that, there are some other terminal questions you can refer. Thank you.